Welcome to the lecture series of Fourier transform. In this video I will discuss about the impulse response of a RLC circuit. To do this we need to know the basic relation as we have discussed in previous video. Basically when a inductor carries a current, the voltage across it would be L di by dt, and the capacitor current would be C dV by dt when it carries the current I, and according for this the voltage would be V. So if you are being you are asked to determine the input output relation or impulse response as like we have discussed in RC circuit. So first of all you need to apply the Kirchhoff's voltage law. In that case the polarity of voltage is according here would be plus and minus for this resistor. So applying Kirchhoff's voltage law, as the voltage across the inductor is L di by dt, so L di by dt is written here. So ultimate goal is to determine the xt in this case. So xt is determined here, and ultimate goal is to determine the impulse response. To have the impulse response we need to have the transfer function, and transfer function is nothing but the ratio of input and output in frequency domain. So here the input in frequency domain, but we need to have the output of the system in frequency domain. So this portion actually present the output of the system. So after having the relation of yt, we will, if we take the Fourier transform, we will get the output in frequency domain. So yt is given by L di by dt. Taking the Fourier transform of yt, basically we will get the output in frequency domain. So how could we get the transfer function? We need to have the ratio between output and input. So when we will able to take the transfer the ratio of input and output in the frequency domain, basically we will get the transfer function. And if we want to determine the impulse response, we need to determine the inverse Fourier transform. But this function actually not in the manner to determine the inverse Fourier transform. So what we should reshuffle or rearrange the particular term. So basically from the property we have solved like a problem like that, when j omega is multiplied with any x omega, where x omega is given by the Fourier transform of xt, then we need to we can perform the inverse Fourier like that. Or from that side, if we go through Fourier transform of that part, just we need to multiply j omega. Or if we have the multiplication like that, x omega with j omega, then we can if we take the inverse Fourier transform of that, we basically able to place the differentiation term. So here if we need to take the inverse Fourier transform, so j omega basically is placed as a multiplication with the j omega plus r divided by L. So basically this property of Fourier transform indicate us to place a first order differentiation. So d dt basically this term represent the Fourier transform of e to the power at ut in this fashion. So we can place this Fourier transformation, and these properties suggest that you need to perform the first order differential equation. So after doing so finally we will get the value of ht. This was the ultimate goal of this problem, to determine the impulse response. So finally I will again request you to practice more and more with having the basic properties and basic transformation of basic Fourier transformation law, you will able to perform this well. And these particular sort of example are so important, and it will, and this video I think will be very helpful for you. And if you have any question, please write to me in any way, like WhatsApp, on Facebook or something like that. Thanks for watching these videos.